Alright, so in this video, we are going to read a blog by Preston Crow. It's going to be about ancient file system, and from the beginning, we can see it's about old operating system like DOS 1, DOS 2, all the way to Sparta DOS. I've never used DOS, I'm only 21 years old, but I think I can learn a lot from this, so we're going to give this blog a shot. Let me just go a little bit bigger. Alrighty. And about the author, he's been doing software engineering for over 25 years. He's a master's degree, and he was smart enough to drop out before completing a PhD. What a legend. Anyways, lessons from ancient file systems. In my previous post, I mentioned that I found a number of oddities when digging through the details of various Atari 8-bit file systems. I read through the specifications I could find online and ran the actual code in emulators to verify and discover details when the specifications were unclear or incorrect. There were some surprising finds. I looked at Atari DOS 1, Atari DOS 2s, Atari DOS 2.0D, Atari DOS 2.5, MyDOS 4.5, Atari DOS 3, Atari DOS 4, DOS XE, Light DOS, Sparta DOS. Atari DOS 1 started all off back in 1979. It supported single-sided, single-density disks that consist of 72 sectors holding 128 bytes each. Doing quick math, that will be 92 kilobytes almost, and that just shows progress from 50 years ago till now. Probably a JSON file is how much was it? 92 kilobytes right now. Anyways, it has some bugs and implementation limitations, so DOS 2.0's S4 single density soon replaced it, making some key changes. Soon other DOS versions started appearing, some trying to maintain backwards compatibility and others trying completely new approaches. I won't go into the technical details, but I do want to highlight what I think are the most interesting design decisions. Keep in mind that DOS 1 was designed when they were planning on selling the base Atari 800 with only 8K of RAM. The 400 would have been only 4K but marketed with a cassette drive instead, so the design minimized the need for additional sector buffers. Hence, the strategy for files was to use the last few bytes of each sector as metadata, including the link to the next sector in the life. Atari used 6 bits at the end of each sector to hold a file number. This was the index of the file in the directory. The other 2 bits and another byte together pointed to the next sector of the file. This was presented in documentation as being there to detect file corruption, which seemed like a waste, as the sort of file corruption almost never happened, but I'm now pretty sure that wasn't the reason the file number was there. Instead, it was to support note and point commands. Atari believed people would use files as a database, and with the sector chaining, it was impossible to jump around in a file without reading it linearly, so a program could note its position in a file, sector and offset, and then return there later with the point command. This is where verifying that the file number in the user supplied sector number matched the entry used when opening the file came in. Without that number, there would be no verification that a point would end up in the right file. In DOS 1, the last byte of each sector was a sector sequence number with the high bit cleared. This was a nice idea and would have been useful if someone were writing a tool to undelete files. If the high bit were set, it was the last sector of the file, and the low bits were the number of data bytes in the sector. In DOS 2, the last byte was instead always the number of data bytes in the sector. The last byte was instead always the number of data bytes in the sector. This would seem to have made the code simpler, but actually the opposite, as DOS2 also included compatibility code for reading DOS1 files, as did DOS 2.5. The real reason is that allowed partially filled sectors in the middle of files, which happened when a file was opened for append, as it would start with an empty write buffer instead of filling it with the data from the last sector. DOS1 didn't have an append option at all. I would have thought it would have been simpler to implement append without partial sectors and avoid needing compatibility code, but apparently not. Several less popular versions of DOS did not support zero-length files. If you open a new file for writing and close it without first writing anything, the file was deleted. That seemed crazy today, but at the time, that was not one of the quirks people complained about. Mostly those DOS versions were unpopular because of incompatibility and issues like wasted space from eternal fragmentation. Only two versions of DOS supported timestamps on files, DOS XE and Sparta-DOS. Nobody wanted to type in the date and time on every boot, and a battery-backed real-time clock wasn't a standard feature of any of the 8-bit computers that I'm aware of. Several versions of DOS supported subdirectories. This was mostly for versions that supported larger disks, like MyDOS and Sparta-DOS. One quirk of Atari DOS 1, 2, and 4 is putting the directory and free sector bitmap table on a track in the middle of the disk. The theory was that this would minimize seek time between reading the directory and reading a file. Not a horrible idea, though it was horribly mangled by an on-off by one error because sector numbers on the drive were 1 base instead of 0 base. As the original coders believed, so there were a seek between the sector bitstamps and the directory. They doubled down on this in DOS 4, where the location of the directory changes depending on the disk format. So larger disks have the directory at higher sector numbers. There was a lot wrong with DOS 4. It probably would have been quite unpopular if it had made it past being a prototype without significant changes. Why? Because they doubled down on this in DOS 4, where the location of the directory changes depending on the disk format. So larger disks have the directory at higher sector numbers, and that would be not very user friendly, I guess. The biggest problem with the official Atari versions of DOS is that they never anticipated future needs. I can forgive DOS 1 as it was developed on a short frame for an 8K computer, and that locked in DOS 2 for compatibility reasons. But DOS 3 was a disaster. Atari had a new drive that could format 130K disks as well as the old 90K disks. So they needed new DOS that would take advantage of the new space, but they ignored other drives with 256 byte, double density sectors, 180K, and the possibility of double-sided disks, 360K, that were already on the market for other computers. Better engineers would have designed something to grow and meet future needs, but instead they just implemented the minimum requirements. So when Atari was later designing the 1450 XLD computer, which did have 360K drives, they had to have a new DOS again. While that was never released, they did develop a DOS for it, which again only handled the specific formats that the drive supported, with no thoughts for the future. On the other hand, the most successful DOS versions for the retro computing Atari community now are precisely the ones that could scale to any drive, namely MyDOS and Sparta-DOS. MyDOS retained DOS2 compatibility but extended it to support up to 16 megabytes drives and adding subdirectories. Sparta-DOS dropped compatibility but was able to support 512 byte sectors, allowing for 32 megabyte drive support. The Atari's I/O protocols limited the system to a 16-bit fill for sector numbers. So the big lesson here is to always plan for the future, listen to the requirements for the current product, but the design with the assumption that you'll be asked to expand the requirements in the future. If you don't, users may be cursing you when the code is released. But who knows? If you do it right, people may be still using your code in 40 years. Alrighty, so this was very short, as you can see, but I'm a little bit curious about Atari DOS, so I'm gonna investigate that for a little bit at least. So here we go. Atari DOS is the disk operating system used with the Atari 8-bit computers. Operating system extensions loaded into memory were required in order for an Atari computer to manage files stored on a disk drive. These extensions to the operating system added the disk handler and other file management features. The most important extension is the disk handler. In Atari DOS 2.0, this was the file management system, an implementation of a file system loaded from a floppy disk. This meant at least an additional 30 kilobyte RAM was needed to run with DOS load versions. So as you can see, the same versions Preston talked about. Similarly, I guess he chose the more popular ones. So here's the Sparta DOS. This DOS used a command line interface, was not compatible with DOS 2 but could read DOS 2.0 disks. Supports subdirectory and hard drives, being capable of handling file systems sized up to 16 megabyte. Wasn't that something here? Did Preston just copy this? No. Excuse me for accusing Preston for such foolery. I'm just kidding. Anyways, being capable of handling file systems sized up to 16 megabyte included the capability to create primitive batch files. Alright, so another question is, what file sizes does Linux support? On 32 bits, file may not exceed the size of 2 terabyte. File system size. File system may up to 2 to the 73 bytes large. However, this limit is still out of reach for the currently available hardware. Alright, so I guess there is storage limit on Linux as well, but it was really a big deal back in the time where the technology was just not there for everyone to have just gigs or even terabytes of storage. And you can just see this was 50 years ago, and since 50 years ago, from kilobytes to terabytes, that's an order of magnitude of a billion. That's crazy. That is crazy. Alrighty, that's it for this blog, and I'm going to have this video in the operating system playlist. Thanks for watching.